Hello guys, welcome once more to another video in our YouTube channel. So in this video we look at the Southwest Regional Mock 2024 Pure Maths with Mechanics paper 3. We are going to be looking at question 5, which came from the topic projectile motion. Don't forget to read the reminder of today. So let's get started. Okay, so I have already displayed the useful information we are going to be using to solve this question. So let's analyze the question together. A ball is projected with speed u meters per second at an angle alpha to the horizontal from the top of a roof 4 meters above the horizontal ground. Given that tan alpha is 314 and that the ball hits the ground at a point which is at a horizontal distance of 8 meters from its point of projection. A. Show that ut is equal to 10 where t is a time of flight, and B. Find the value of u. Like I said, I already displayed what is happening to you. So the ball is projected at the top of from the top of a roof which is 4 meters above the ground. So the horizontal surface here is a ground. The ball is projected from the point A. It hits the ground at a point B. So it is actually projected from the top of a roof, and the distance separating the top of the roof and the horizontal ground is 4 meters. That's the distance. Okay, so the ball covers a total horizontal distance of 8 meters. All right, so the distance from the basement of the roof, okay, right up till where the ball hits the ground is 8 meters. That's the total horizontal distance covered. Okay, so the initial speed, that's the velocity of the ball, the speed of the ball makes an angle of alpha with the horizontal. So when that happens, we need to resolve that speed into the two components where we have the horizontal component and the vertical component. The horizontal component will be u cos alpha and the vertical component will be u sin alpha. If you have a problem with projectile motion, check out the video that is displayed to you. You are going to, maybe at the end of this video, you can check that video and you're going to better understand projectile motion, the basics of projectile motion. All right, so we have the horizontal and vertical component of the speed. Okay, so the first question is asking us that we should show that ut is equal to 10 where t is a time of flight. All right, so projectile motion is motion in 2 dimensions. We have motion in the horizontal and motion in the vertical. So t is a time of flight, and this time of flight we can interpret it as the time taken by the ball to cover the total horizontal distance of 8 meters. Okay, so we can use that fact and then we come out with a proof. So if we are dealing with the horizontal, then we can talk about the motion along OX. All right, so OX is my horizontal. So if I analyze the motion along the horizontal, I need to deal with distances because I know the total horizontal distance traveled, and the time to travel that total horizontal distance is a time of flight. So we need to say, okay, in the horizontal direction, the horizontal distance, generally S is equal to ut plus half at squared. But if I am the horizontal, I'm going to call Sx is equal to uxt plus half ax t squared. All right, now in the horizontal direction there is no acceleration, so the acceleration is 0, which means that our Sx will just be equal to ux times t, because in the horizontal direction acceleration is 0. A very important point to note. In the horizontal direction there is no acceleration. All right, now what is ux? Ux here is basically the initial speed of the ball in the horizontal direction. All right, so the initial speed of the ball in the horizontal direction is u cos alpha, and the SX here is actually the total horizontal distance traveled, because the time I have replaced here is a time of flight. If I just place small t, then without it being the time of flight, then we kind of maybe replace SX here with just the distance covered in time t, and here the distance covered in time t, which is the time of flight, is 8 meters. So I replace ux with u cos alpha, because u cos alpha is a horizontal distance, the initial velocity in the horizontal direction. Okay, now what happens from there? From there, you realize that we can divide both sides by cos alpha, right? We can divide both sides by cos alpha, because in the proof we have u and t already. Now, since you are given that tan alpha is equal to 3 divided by 4, and clearly alpha is an acute angle, this angle is found in the first quadrant. Okay, it therefore means we can create a right angle triangle where if tan is 3 over 4, it means that the opposite to the angle is 3 and the adjacent to the angle is 4. We can find the hypotenuse, and the hypotenuse is going to give us 5 if we use the Pythagorean theorem to get the hypotenuse. We are doing that because we need to get a cosine of alpha. Alright, so what is cos alpha? Cos alpha is basically equal to the adjacent divided by the hypotenuse. The adjacent is 4 and the hypotenuse is 5. So 8 will be equal to u times 4 divided by 5, then times t. 4 divided by 5 is cos alpha. So from here, I think we can just simplify. We multiply both sides by 5. We get 4t is equal to 4ut. Then we divide both sides by 4, and we get ut is equal to 10. So here is a proof. So you have successfully proven that ut is equal to 10. Okay, now the second question, we need to find the value of u. So this time around, we are going to consider motion in the vertical direction, that is motion along OY. Now, to get motion along OY, we are also going to deal with the vertical distance traveled. Okay, now this time of flight, which is capital T, in as much as it is a time taken to cover the total horizontal distance of 8 meters, it is also the time taken to cover the vertical distance of 4 meters plus this distance. Okay, because the total vertical distance is actually this little distance up here. If I try to create the horizontal like this, so we need to take the total distance traveled up plus the total distance traveled downwards, and the total distance traveled downward is 4 meters. Okay, while the total distance traveled upwards, we can just call it, we can just give it any value. So that time of flight is also the time taken to travel that distance. Okay, anyways, let us try to get the total vertical distance traveled. So we know that s is equal to ut plus half at squared, but this time around our s will not be equal to ut plus half at squared, because we never started at the origin. So our s, instead, if we are dealing with the vertical direction, will be equal to the distance at the point A from the ground plus ut plus half at squared. This is what I'm trying to say. I'm saying that the total vertical distance traveled will be, first of all, we need to add the vertical distance initially from the ground, then plus the total vertical distance traveled from the point of projection. So this sy here is actually the total vertical distance traveled with respect to the ground. All right, so we need to take the distance that it was above the ground initially plus now the distance it is going to travel from that point of projection. So since I'm in the vertical direction, I'm going to be using sy. Now you need to know that in the vertical direction there is acceleration, and acceleration is negative g. Now at the point B, okay, at the point B here, at the point B, the vertical distance traveled is 0. All right, and the time taken to travel that distance is also capital T. The acceleration, since we are considering the vertical direction, is negative g, and g is 10 meters per second squared. So the vertical distance traveled at the point B. The point B is on the ground, all right, and at the ground you just have, there is kind of no vertical distance, and the horizontal distance is 8 meters. So that's why I need to use that, okay, because it will be very tedious for me to calculate this distance up here and add it to 4 and equate it to SY. It's going to be a little bit complicated. But if I just use the fact that when it is at the ground, the vertical distance there is 0, while the horizontal distance is 8, then I can find the value of u. So I just need to replace SY with 0. My 4 remains 4. My UYT remains UYT. My half GT squared becomes minus GT squared divided by 2, because we are going against gravity when we are going upwards. So your A is negative g. Now what is uy? Uy is the initial velocity in the vertical direction, and the initial velocity in the vertical direction is u sine alpha. All right, that is it, u sine alpha. That's the initial velocity in vertical direction. So my uyt becomes u sine alpha times t. Okay, but we can rewrite this as ut sine alpha, because we know that ut has been proven to be 10, and we can find sine alpha. From here, the sine of alpha is the opposite, which is 3, divided by the hypotenuse, which is 5. Now our g is equal to 10 meters per second squared. So I'm just going to replace and simplify everything so that we see what we have. Okay, so from there we can subtract 4 on both sides, so we get 0 minus 4, negative 4. Now remember that we have to do ut sine alpha. Ut is 10, y sine alpha is 3 divided by 5. Now g divided by 2 is 5, because g is 10. Okay, then we have t squared. T can be gotten from the first proof, because from the first proof we have that t is 10 divided by u. Okay, then now we need to square. From there, all we need to do is we simplify and make u the subject of the formula. So when we simplify, the first term we have 6, the second term we have 500 divided by u squared. We need to subtract 6 on both sides, and then we divide all through by the negative sign, and we have u squared to be equal to 50. But 50 is the same as 5 squared times 2, and when we take the square root on both sides, since u is positive, we get u to be equal to 5 times 2 meters per second. So this is the actual value of the initial speed of the particle, of the ball. Okay, now the last part of the equation, it says, as the ball hits the ground, its direction of motion makes an angle of phi with the horizontal. Find the tangent of the acute angle phi. All right, so already displayed to you, when the ball hits the ground, practically its velocity will be given the direction of motion. The velocity will be in this direction, and it's going to be making an angle of phi with the horizontal. So the final velocity, we have a vertical component, and we also have a horizontal component. So from there, I think we can pick up from there, and we analyze motion in the vertical direction and also in the horizontal direction. So if I consider motion along the horizontal, I need to find the final velocity along the horizontal and the final velocity along the vertical. Then from there I can get the tangent of the acute angle, because the direction of the ball makes an angle of the direction of the ball. We always take the velocity. Okay, all right. So along OX, remember that we know V is equal to U plus AT. So along OX, I'll have VX is equal to UX plus AX times T. But remember that there is no acceleration in the horizontal direction, so it therefore means that Vx will just be equal to Ux. Okay, now what is ux? Ux is the initial velocity in the horizontal direction, and that initial velocity is u cos alpha. So we have vx to be equal to u cos alpha, but we know that u is 5 root 2, and we know that cos alpha was 4 divided by 5. So it therefore means that our vx is 4 root 2 meters per second. You see, it is positive, pointing to the right, so it is positive. Now let us analyze motion along OY, and we find the final velocity of the ball in the vertical direction. Clearly, since it is pointing downwards, it has to be negative. Okay, it is pointing downwards, so it definitely has to be negative. Okay, so Vy will be equal to Uy plus Ay times T, but we know that Ay is negative G, so we have Uy minus GT. Okay, now from there, what do we have? What is Uy? Uy is the initial velocity in the vertical direction, which is u sine alpha. Okay, that is Uy, so we replace Uy with u sine alpha. Now G is actually 10. Sorry, I wrote 5, it's supposed to be 10. Okay, G is supposed to be 10. Then we now also need to multiply with T, where T is the time of flight, because when it is hitting the ground, the total time taken is a time of flight. Okay, so from here I just have to simplify. We have to simplify. Now what is u? U was 5 root 2. Okay, what is sine alpha? Sine alpha was 3 divided by 5. Okay, now next thing is, remember that this was supposed to be 10 actually. Okay, this was supposed to be 10. Now what is t? Remember that we saw previously that ut was equal to 10. We saw that ut was equal to 10. So what is t? T is 10 divided by u. Okay, 10 divided by u. All right, so t being equal to 10 divided by u, our u was 5 root 2. Okay, so basically we need to have, remember that what I said, this 5 is supposed to be 10. Okay, so it's a little error. So all you need to do is to simplify, and you're going to get my response using the 5 as 10. Okay, so you're going to have negative 7 root 2 meters per second. Like I said, it's supposed to be negative. Okay, so replace the 5 here with 10. The 5 here cancels the 5 here, and we are going to be left with 3 root 2. We have 3 root 2. Now from here we actually have here, like I said, it's supposed to be 10, so we have 100 divided by 5, which is 20. So it is 20 divided by root 2. Okay, there, 20 divided by root 2 is the same as 20 times root 2 divided by 2. You just have to simplify, divided by root 2 as well. Yes, sorry. And you realize that root 2 times root 2 is 2, and 20 divided by 2 is 10. So at the end you have 10 root 2. So you have here 3 root 2 minus 10 root 2 gives you negative 7 root 2. So please try to simplify following the correction that I have done, and you're going to get your response perfectly. So the velocity of the ball is equal to, is a vector quantity, so we need to take the velocity in the horizontal and we attach it to I, plus the velocity in the vertical, we attach it to J. That's the final velocity. So we just have to have 4 root 2I minus 7 root 2J meters per second for sure. All right, so that's actually the final velocity when it hits the ground. So when they say its direction of motion makes an angle of phi with the horizontal, they actually mean that the final velocity makes an angle of phi with the horizontal. So the tangent of the angle will just be equal to Vx over V. It's supposed to be Vy over, Vx over Vy. Yes, Vx over Vy, because the tangent of phi here, if you look at this angle here, this angle is kind of like this. We have a vertical, okay, the angle, this kind of the hypotenuse. All right, So the vertical, this vertical is the same as this vertical here. Voila. So this vertical component here is actually Vy, while the horizontal component is actually Vx. Now the hypotenuse is actually the V, and this is the angle here. So if I take the tangent of this angle, okay, I'm going to have the opposite, the opposite over the hypotenuse, the opposite over the adjacent. The opposite to that angle is actually Vy, and the adjacent is Vx. So this is supposed to be Vy over Vx. Okay, and our V, very big error. So sorry guys for the error. So remember that you have to switch. It's supposed to be Vy over Vx. So the denominator will go to the numerator, and the numerator will go to the denominator. Okay, and when you do that, you are actually going to have -7/4 and not -4/7. So try to correct my little errors. Those are just typing errors when I was solving the equation. All right, so thank you guys for watching, and see you in the next video.